Hi, I'm Jamie Bunker. I'm a 4th grade teacher at Manchester Elementary School. And in 4th grade, students are learning an alternative to the traditional algorithm for dividing. So in class, students are building their understanding of division using lots of concrete models and manipulatives. These are base 10 blocks that students have used in class to divide. This block is 100. This stands for a 10. And this stands for a 1. I'm going to show you how to divide 3-digit dividends. Like this problem, 564 divided by 4. And so I've built a model of 564 using 5 hundreds, 6 tens, and 4 ones. One way to think about this problem is to think about 564 blocks being divided into 4 equal groups. And so now that I have a model built of 564, I want to show those 4 groups. I'm going to rewrite the problem so that we can keep track of what's happening as we divide. 564 divided by 4. We want students to think about dividing and starting with the largest place value. So in this case, we know right away that we have 5 hundreds and 4 groups. Even though we can't divide all of those hundreds equally amongst the 4 groups, we can at least divide 100 into each group. And then we want to keep track of that thinking and what we've divided in our model. So on the outside, we'll keep track of how much has been divided into each group. And so far, there's 100 in each group. Then on the inside, that was our total. We started with 564. We want to see how much there's left to divide. So we want to subtract the amount that we used when we divided. I'm subtracting 400 because we divided 100 into each group. So 100, 200, 300, 400. 564 minus 400. 6 minus 0 is 6, and 5 minus 4 is 1. So we have 164 remaining. Now, the benefit of the model is that students can go back and see, here's my 100, I have 100, 6 tens, and 4 ones. So this helps to check and make sure I'm on the right track and my answer is making sense so far. Now, with 4 groups, again, we can't divide this 100 evenly. So we need to think about this 100 as 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now instead of 100 and 6 tens, we have 16 tens and 4 ones. So now when I think about dividing amongst those 4 groups, I can think about dividing 16 into 4. Well, I know that 4 times 4 is 16. I should be able to divide 4 tens equally into each of those 4 groups. And then our last tens. So again, we want to keep track of what we've done in our model. We divided 4 tens into each of the groups, which is also 40. So we want to record 40 on the outside. And again, on the inside is how much we have left to divide. So as you can see, we divided 40 into each of our groups. Again, we want to keep track of how much we used altogether. When you put 40 into each group, we've divided 160 total. We're going to subtract to see how much we have left to divide. 4 minus 0 is 4, and 16 minus 16 is nothing. We have 4 ones left. And again, let's check our model. There are 4 ones remaining. So the model helps to scaffold and have students think about what makes sense. And they're definitely on the right track. There's 4 groups, and there are 4 ones remaining. So I know that I can divide 1, 1 into each of the 4 groups. And then we'll record. Just going to make that line a little bit longer. We put 1, 1 in each group, which means we used 4 altogether, and we have none remaining. And again, that's what our model shows. We have nothing left to divide. So to find our final quotient, we're going to add the partial quotients together. 100 plus 40 plus 1 is 141, and I'm going to record that on the top. Using the model, we can check to see there really is 100, 4 tens, and 1 1 in each group. So 564 divided by 4 is exactly 141. So the partial quotient strategy is a way to help students understand dividing 3-digit numbers.